Our solar system is a busy place. It's not just home to the sun, planets, and moons. There are other, smaller objects traveling through space. We call these objects asteroids. They're like giant rocks, leftovers from the time when our solar system was born. Billions of years ago, when the planets were forming, not all the material came together. Some pieces were left behind, floating in the vast emptiness. These remnants became the asteroids we see today, each one a silent witness to the ancient history of our cosmic neighborhood. Most of these space rocks live in a place called the asteroid belt. This is a huge, donut-shaped region located between the orbits of Mars and Jupiter. Here, millions of asteroids circle the sun, from tiny pebbles to giants hundreds of miles across. They're not packed tightly together like in the movies. Instead, space is so big that they're very far apart from each other. They're like lonely travelers on a vast circular highway around our star, each following its own path, a cosmic dance choreographed by gravity since the dawn of our solar system. Sometimes, the powerful gravity of a big planet like Jupiter can change an asteroid's path. A gentle nudge can send an asteroid flying out of the belt. Its new journey might take it on a different course, one that could cross the paths of other planets, including our own Earth. These are the asteroids that we need to watch. They're no longer just distant rocks in a far-off belt. They've become cosmic nomads, their trajectories now bringing them into the inner solar system, where the potential for a close encounter with our world becomes a real possibility. These wandering asteroids are made of different materials. Some are mostly rock and stone, like the rocks you might find on Earth. Others are made of metal, like iron and nickel. And some are a mix of rock, ice, and other compounds. By studying these visitors from deep space, we learn more about the building blocks of our own planet. They're like time capsules, carrying the secrets of what our solar system was made of long, long ago. Each one holds clues to the story of our origins, a physical record of the primordial soup from which all the planets were cooked. When an asteroid gets close to Earth, our planet's gravity pulls it in. It starts to fall towards us, moving incredibly fast. This speed can be many thousands of miles per hour, much faster than any jet plane. As it begins its final approach, the asteroid accelerates, pulled by the relentless force of our world's gravitational field. It's no longer just an object floating in space. It's become a projectile aimed at our planet, a cosmic bullet on a collision course. The silent journey through the vacuum of space is about to end with a dramatic and violent entry into our atmosphere. As the asteroid plummets, it hits the air surrounding our planet. This air is our atmosphere, a protective blanket of gas. The asteroid pushes through the air at such a high speed that the air in front of it gets compressed and becomes extremely hot. This intense heat makes the asteroid glow, turning it into a brilliant fireball. We sometimes call this a meteor or a shooting star. It's a spectacular, fiery streak across the sky, a beautiful but potentially dangerous display of cosmic physics in action, a testament to the immense energy released when space and Earth meet. This journey through the atmosphere is a tough one for the asteroid. The intense heat and pressure can cause it to break apart. Smaller asteroids often burn up completely before they can ever reach the ground. They turn into nothing more than dust, which gently settles down on Earth. Only the bigger, stronger asteroids can survive this fiery ordeal. They shed layers of rock and metal, blazing a trail of debris behind them. But their core continues its descent, determined to complete its journey from the cold of space to the surface of our world below. If a piece of the asteroid survives and hits the ground, we call it a meteorite. Finding a meteorite is special. It's a piece of another world that you can hold in your hand. Scientists study meteorites to understand where they came from and what they're made of. Each one is a physical message from the asteroid belt, a tangible link to the cosmos. It tells a story of a long and violent journey, ending here on Earth, offering us a direct sample of the raw materials that built our solar system billions of years ago. Imagine a very large asteroid, maybe miles wide, hitting the Earth. The impact would be more powerful than all the atomic bombs in the world combined. The moment it strikes, it would create a massive explosion. This explosion would dig a huge hole in the ground called an impact crater. Everything near the impact site, cities, forests, mountains, would be instantly vaporized. The shockwave from the blast would travel around the planet, leveling buildings and trees for hundreds or even thousands of miles. a force of unimaginable destruction unleashed in a single terrifying instant. The impact would throw enormous amounts of dust, rock, and debris high into the atmosphere. This cloud of material would spread out and cover the entire planet like a thick blanket. It would block out the sunlight, plunging the world into a long, dark twilight that could last for months or even years. Without sunlight, the Earth's surface would become very cold. This period is often called an impact winter. The familiar cycles of day and night, of warmth and light, would be replaced by a persistent, chilling gloom, altering the fundamental climate of our world. This dramatic change in the environment would be devastating for life on Earth. Without sunlight, plants would not be able to perform photosynthesis, the process they use to make food. As the plants die, the animals that eat plants would run out of food and starve. Then, the animals that eat other animals would also face starvation. The entire food chain would collapse, from the smallest organisms to the largest creatures. The intricate web of life, built over millions of years, would unravel in a very short time, leading to mass extinctions across the globe. One of the most famous examples of such an event is the asteroid impact that happened about 66 million years ago. Scientists believe a large asteroid about 6 miles wide hit the Earth in what is now Mexico's Yucatan Peninsula. This event created the Chicxulub crater. The resulting environmental chaos is thought to be the main reason why the dinosaurs, along with about 3/4 of all plant and animal species on Earth, went extinct. It was a pivotal moment in our planet's history, a stark reminder that life on Earth is vulnerable to events from the cosmos. The story of the dinosaurs serves as a powerful warning. It shows us that asteroid impacts are a real threat that we must take seriously. Unlike the dinosaurs, however, we have science and technology on our side. We have the ability to look up at the sky, understand the danger, and potentially do something about it. We're the first species on Earth that can consciously protect itself from a cosmic catastrophe. This unique position gives us not just a capability, but a profound responsibility to act as the guardians of our own planet and all the life it holds. Today, scientists all over the world are working hard to find and track asteroids whose orbits bring them close to Earth. These are called near-Earth objects, or NEOs. Using powerful telescopes on the ground and in space, astronomers scan the skies every night. They catalog new asteroids, calculate their paths, and predict if any of them might pose a danger to us in the future. This global effort is like a planetary neighborhood watch, a constant vigil to identify any potential threats long before they become an immediate problem for us. What if we find a large asteroid heading directly for us? Scientists are developing clever ideas for how to protect Earth. One idea is to send a spacecraft to collide with the asteroid. This is not to destroy it, but to give it a small push, just enough to change its course so that it misses our planet. This is called a kinetic impactor. In 2022, NASA's DART mission successfully tested this very idea, proving that we can indeed alter the motion of an asteroid in space, a monumental achievement in planetary defense. Another concept is to use a gravity tractor. This would involve sending a heavy spacecraft to fly alongside the asteroid for a long time. The spacecraft's tiny gravitational pull, over many months or years, would slowly tug the asteroid onto a new, safer path. These are not ideas from science fiction. They're real strategies being developed by brilliant minds. It's a testament to human ingenuity that we are no longer helpless spectators to cosmic events. We're actively preparing to defend our home, ensuring that Earth's story continues for a long, long time.